I'm gonna need you to stop. 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 So you're sitting at the screen thinking to yourself, I'm a coder and I'm going to be virtually coding. What's that mean? Well, today you're going to work with a partner to code in order to complete a wall maze plus. So you can see in the picture here, this is the wall maze that you're going to do, and what I'm going to show you in this video is how to approach it. It's standard block coding, so you've done this with this Rubin, but I want to show you the ins and outs of Xcode VR. So in order to do this, what you got to do is you've got to actually go to Google Classroom. Once you're in, you're going to go to Classwork, and you're going to see a Vex VR link. What this does is this is going to take you directly to Xcode VR. Now, as it's loading, I'm going to explain to you that I have set up a Google Classroom, not a Google Classroom, Xcode Classroom, that allows you to actually use certain playgrounds that are not normally available to you. And so it's important that you click on that link. So please do not go to vr.vex.com by typing it in. Go to the link in Google Classroom. And from there, you're going to select a playground. Now, once you select a playground, there's going to be some that we have to have premium license for. And I'm considering those, but I have not made for certain if we're going to do that because it is expensive. But this one is actually coding for Slapshot, our game. But today, you're going to be just getting the basics in and outs of coding to actually figure out how to code a robot using Xcode and get a chance to practice those skills by thinking about a maze, just like you did with your partner when you walked through blindfold. So the one you want to click on is the Wall Maze Plus. Make sure you're clicking on Wall Maze Plus and you are not clicking on the dynamic wall maze because that one is not nearly as good as this one. Nor clicking on the regular wall maze. You want Wall Maze Plus. So from here, once you click on it, it's going to pop up on your screen. It's going to load, and sometimes it takes a little bit of time. It does like to crawl. But as it's loading, let me explain some of the options over here on the left side. So I'm going to move this over while it's loading. Okay, and I'm going to let it do its thing. It does take a minute. But as you're looking on the left side, I want you to note some things. Number one, there's a drive forward command. There's a drive forward 200 millimeters command. There's a turn right. But I want to talk to you about some of these codes. Robots only listen when you tell them exactly what they are doing. So if you tell a robot to drive forward, let me show you. If you tell a robot to drive forward, I'm going to put this code over here. Watch what happens on the screen when the robot is told to drive forward. A robot doesn't understand how far to drive. So the robot drives completely forward and never stops. And you end up running into a wall. Now, the great thing about this playground is every time you have a collision, it starts you over. So you're going to have to be very careful about your collisions. But also, back to this drive forward command. This drive forward doesn't have a determined distance. You see, a robot needs to know how far. So we're not going to use a drive forward command. We're going to use a drive forward command involving a set distance. It's really important that you make sure these codes snap in place just like you do in Scratch. And what we're going to do for this is we are going to use millimeters. You do have the option of switching to inches, but when we start coding with our robots in real life, we're going to be using millimeters, so you're going to stick to millimeters. Now let's talk about the playground now that it's loaded. As you can see on the playground, there's a map. So in your document where you guys can actually record, you can think of a way on how to attack this. You can say, okay, I can see how to get through this maze. Now it's my job to plan how to get there. There are multiple ways to get there. Some are faster than others. The goal of this is to get there in the fastest way possible. So let's start by simply thinking about some strategies. Number one, what you can do is if you actually click on this and drag a little bit, you can actually move around and see different views. You'll notice that there are certain squares. Now, I am not going to tell you how far those squares are. It is going to be up to you to determine and figure out how far those squares are by testing different distances. So for example, let's say I tested 200 millimeters. Once I press 200 millimeters, I'm going to press play. Now this is my first code. Now you'll notice it did not take me completely there. So I'm going to reset my robot. You see, I want to get to my first point and then be able to make a turn. So for my first point, I'll go ahead and give you the possible answer here. Let's see. If I come up to it, I do believe the answer is 900. And if I do just that, I'm going to go ahead and press play. And from there, 900 takes me directly where I want to go. And so now it's all about thinking about my next move. I know my first code. What's my next move? You can see your robot here on the map, and you can start to begin to plan your next move. Well, your next move is going to involve a turn. So I can turn, and there are ways that you turn. You could turn left or right, just like in real life, but you have to tell the robot how far to turn. If you tell a robot to just turn right, let me show you what happens. When you tell a robot just turn right, we're going to reset here because you're going to reset after every time. Watch what happens when you just turn right. Robot goes 900, and it's going to turn right and never stop turning right. You have to tell the robot how far. So we're going to move that right command off. We're going to take the right command over. We're going to say, how far right do we want to go? Well, if you remember, a 90-degree turn is exactly to the right. It's exactly 90 degrees. It's going to give you that perfect corner. So if I press 90 degrees, I'm going to stop and turn perfectly. And now I'm facing the direction that I want to go, and I can start to plan this out. So as a strategy for doing this, what you can really consider is all of your steps. And remember, each time you do this, you're going to reset once you get your new plan to see how well it goes, because you want to be able to record your time when it comes to your recording sheet. Now, once you're going through, there are some other things that you could play with. Take note of these dry velocities down here. Velocity has to do with your speed. You see, right now, your speed is custom set at our standard set at 50%, but you can make that speed faster, but it comes with a warning. If you make your speed faster, turning does become a little bit more difficult, because when you try to turn at a faster speed, it does create some issues for you. And those are things that you're going to have to figure out. So you can increase your speed, but you must understand it's going to cause some issues. You're also going to have to figure out, where do I place this code in order to set my drive velocity to make it faster? You see, I'm not going to tell you the answer to that. It's up to you. The only answers I give you are how to get to the first turn, which is drive forward 900 millimeters and turn right 90 degrees. You're going to have to think to yourself, okay, how far is it to the middle of this square? And if I could figure out how far it is to the middle of this square, I could figure out how far it is to the middle of the next, and so on. And you can really start to plan out your route. So as you guys are doing this, you're going to be recording some information in your recording sheet. Your recording sheet looks like this. You're going to draw the path that you're going to take. Once you actually complete that path, you're going to record how long did it take you when you press play until you reach the goal zone, which is the red zone. And then you're going to think of another path. There's got to be another way, right? Is that other way faster? I want you to code that one as well and see if you can make it faster. Then I want you to draw another path, or maybe work and play with your velocity to see if velocity changes how fast you can get there. The goal is going to be to get there as fast as you possibly can, so that way you can improve on your time in the fastest time possible. Good luck and enjoy VEX Code VR.